Welcome back to another Algebra 2 video. I'm Mr. Hibble. Today we're going to be looking at solving polynomials by graphing. This is our 5.1 unit. We've finally made it there. But let's look at solving polynomials. Remember, polynomials are just those curves that kind of go up and down. They're kind of those just snaking curves that just changed directions a bunch, where we had maximums and minimums. They were increasing and decreasing and had x-intercepts and all of that stuff we looked at in Unit 4. Now what we're doing is we're going to start to solve these equations. There's various methods to do that. The first method we're analyzing is graphing. Graphing is the most basic method because we're just going to be using Desmos to do the graphing for us. In order to solve by graphing, one method that you might use, the method we're going to be using, is by creating a system of equations. A system of equations just means you create two different equations. One that has the left side of the equal sign, and the other one that has the right side of the equation. Notice I'm setting both of those equal to y. Since they're now both equal to y, what we're going to do is we can now just type those in. I've already typed in both equations into Desmos, and it gives me a graph like this. Well, what we're trying to do is we're trying to solve the polynomial. And a solution to a polynomial then, graphically, is where the lines are the same. Well, if your lines are the same anywhere, that means they're at the exact same point. Well, if they're at the exact same point, the only time that's going to occur is when they're overlapping, or where they intersect, where they cross, right? And as you notice, there is a spot where the red and the blue line cross here. That is our solution. But we don't care about both of those values. We really only care about one of them. Let's talk about that in just a moment. So we have 0.034 roughly. Okay, and my graph looks something like this. We saw that the solution is right here at 0.034, comma, whatever. Okay, but the reason I only wrote the x value is notice the variable we were trying to solve for originally. We were trying to solve for x. So when I look at my intersection on the graph, I only care about one of the values. I only care about whichever value we were finding originally, which is x. My solution is 0.034. Okay, but let's go back and let's look at that. The thing about polynomials is they can have more than one solution. So different things you might note about Desmos. If you scroll just on the axis, I'm only touching the x-axis here, that will just change that dimension. If you just touch the y-axis, that will just change the y dimension. Okay, you can scroll on those compared to just scrolling further away just anywhere. Notice now our graph does touch a second time. It touches or crosses here as well, where the x value is also 2.153. So we find there's a second intersection where x is 2.153. You do get two solutions. Those are both of the values for our solution. Well, one thing we might be asked to do as well is just figure out how many solutions do these systems have. And again, a solution is where they cross. So if I want to know how many, you might look at the graph, find how many times they cross. In this case, it looks like there are two intersections. That would mean there are two solutions to this system. Check the other ones. This one looks like it would be one solution. Oops. Check this third one over here. I believe these lines cross 1, 2, 3 times, giving us 3 solutions for that system. Solutions are where they cross when we are graphing a system. Let's look at some word problems, though. This is where things might be a little bit more challenging. So it says, while hunting, Scott shoots an arrow from a 23-foot platform at some trophy buck, according to this equation. So that initial part's just setting up where this equation comes from. They tell us the units. H is the height in feet. T is the time in seconds. But when Scott shoots his arrow, it misses and it hits a tree instead, where Scott finds that the arrow hit the tree at a height of 3 feet. We're being asked how long it took for the arrow to hit the tree. Well, we're given an equation that models the height versus the time. And we're given one of those values. We're told that the height, h, is 3. So what we're allowed to do is if you know what something's equal to, you can always replace it. So in our equation, instead of the h of t equals, what I'm going to do is I'm going to replace the h variable. In this notation, when you replace h, that is technically h of t, you're replacing that entire thing with that value of 3. Well, now this is just a system that we can solve. We can take the left side, make it one equation. We can take the right side, make it the other equation. When you know what something is equal to, plug it in, type them into Desmos, find your solutions for this one. Okay, so as we type them in, you had y equals 3 for one of them and y equals negative 16 t squared. Notice Desmos is okay with the letter t. That is only when you have the y equals. Okay, so that's why we like to use it. Make sure we have y equals for this. We check on our two spots where they cross and we have our solution. But what this is telling me is there's two solutions. That would mean there's two separate times that the arrow hit a tree. Well, we know that's not true. You shoot an arrow, it hits the tree. That only happens once. It doesn't happen multiple times. So we only care about one of these. We know that if you shoot an arrow, it's going and it hits a tree. However long it takes has to be a positive amount of time. Notice this left side here, your t value, your x value there, the time is negative 0.25 seconds. We know that's not true. The arrow hit the tree over here after 5 seconds. So now that we have our answer, t equals 5, we know seconds all along. They told us that originally. We have our answer for that word problem. Let's go check some other word problems, see how that stuff might work. This is another one we did in class. You're told some different things where you're finding volume. So we can go ahead, find volume of whatever this is. It's a shipping package. Remember, volume is just length times width times height for a box or some rectangular prism. And what they tell us is that the volume is this 15,000. So again, if you know what something's equal to, replace it. They tell us that the length of this box is 3x minus 5. So I replace the length. I replace the width with however wide it is. And I replace the height with however tall it is. Again, you have your equation. You could type in your two equations into Desmos and find where they cross. So y equals 15,000. Y equals our different parts. That was 3x minus 5, 2x, and x plus 20. Again, zoom out. Notice one of your values is 15,000. You're probably going to have to zoom out quite a bit. Again, you can pinch the y-axis to just change that dimension. And we end up getting now our value for that. We end up getting they cross at 10, 15,000. Again, we're not going to have a negative value. I'm not going to look at the other side there. We know that x is equal to 10. In this case, though, they're not asking us to just solve for x. They say, what is the dimensions of the box? That is the final question here. So if we want to know the dimensions, we need to figure out how long it is, how wide it is. And they told us those parts. They told us that the length was 3x minus 5. But again, we know what something is equal to. If you know what something is equal to, you can replace it. So the x was equal to 10, so I get rid of it, I plug it in, and find the final value. The length of our box is 25 centimeters. We do the same thing with the width as well as the height. We know what x is equal to, so now we can replace it to find the actual dimensions. 20 centimeters for the width, and I believe the last one comes out to 30 centimeters for the height. Those are the dimensions she would need to have a box that is 15,000 centimeters cubed in volume. Another interesting one we might look at, we'll just create the equations for this one. We won't necessarily solve it. What it says is Andrew and Ethan are brothers. Andrew is older. The sum of their ages is 30. Well, let's say that Andrew's age is just the letter A. Let's say Ethan's age is the letter E. We know that the sum of both of those ages, sum is addition, is 30. Remember, the word is means equal in math. They also tell us that the product of their ages is 216. Well, their ages are A and E. Product means multiply. And again, the word is means equal. Now I have my two equations. And again, you could solve. Since you have two equations already, you can just use those two in Desmos. You don't need to make it y equals. So x plus y equals 30. Notice I am using x and y now instead of a and e. Desmos would not like a plus e equals 30. It does not know what to do. So make sure that if your letters are on the same side, you're using x and y there. So x times y equals 216. And now you could find their ages where they cross. In this case, it looks like they cross twice. Notice they're the same x and y values, 12 and 18. So if you knew that Andrew is older, Andrew must be 18 years old. Ethan must be 12 years old. Their ages do add to 30, and if you multiply those, they do multiply to 216. Thanks for watching. That is our Algebra 2 video for 5.1, solving by graphing, as well as some context in word problems.